Hello, mathematicians. I hope everyone is doing well. Today we're going to talk about area and perimeter, and we're going to investigate whether it's possible for two unlike shapes to have the same area but different perimeters. You might remember area and perimeter from some of my earlier lessons this year, but let's quickly review what they are just in case. So remember that area, usually depicted by an A, is the measurement of what is inside of a shape, and perimeter is the measurement around the outside of a shape. To do our investigation today, I'm going to just shrink myself. We're going to use these really cool things. I love these, and you probably recognize them from one of your classrooms in the past. And they are called exactly what they look like. They're colored tiles. The really cool thing about colored tiles, well, there's a lot of cool things, but colored tiles are exactly 1 inch by 1 inch. And so when you're using them as a manipulative in your classroom, you don't need a ruler. Hello. We already know they're 1 inch by 1 inch. So there are all kinds of things you can do with colored tiles. I like them mostly because they can help us learn about math. And anything that helps us learn about math is priceless. So today I'm going to use these tiles, and I'm going to make two shapes that we're going to measure. I don't have any colored tiles here, so I just made some on my Word document because I'm awesome. So I'm just going to make a shape here, and then I'll come over here and make another shape here. These are not going to be perfect because I'm just using my little trackpad on my laptop. Yeah, that's good. Let's just do that. We can actually just get rid of these extras here. So for shape 1, area, you can see up here I have written that area, A, is the length times the width, and perimeter is the top length, the bottom length, the left width, and the right width, and you have to add those all together. So for this first shape, we need to find out the length, 1, 2, 3. So we know the length is 3, and we're going to multiply that by what? By the width. The width is 1, 2. And 3 times 2 is what? 6. And we are going to be sure to label our answer. Does it need to be capitalized? Okay. The area of this first shape is 6 square inches. So now let's measure the perimeter. And the perimeter, again, is the outside of a shape. It has 2 lengths, and it has 2 widths. So 1, 2, 3. So our first length is 3. Oops. Our bottom length, 1, 2, 3, is 3. The width over here on the left is 1, 2. And the width over here on the right is also 2. And when we add those together, we get 3 plus 3 is 6, plus 2 is 8, plus 2 more is 10. 10 inches. The perimeter of this shape is 10 inches. Let's move over here to shape number 2. So again, area is length times width. So let's see what the length is. 1, 2, 3, 4, 5, 6. 6. And we have to multiply that by the width. Well, the width on this one is simply just 1. And 6 times 1 is 6. Now, for the perimeter, we just discovered the length was 6. So now we're sure the bottom length is 6 also, but we can count just to make sure. 1, 2, 3, 4, 5, 6. And now the 2 widths. Over here on the left we have 1. And over here on the right we have 1. And now we add those together. 6 plus 6 is 12, plus 1 is 13, plus another 1 is 14. The perimeter of the second shape is 14 inches. So really quickly, you can see when we compare the areas, we have 6 square inches in this shape and 6 square inches in this shape. And for the perimeters, we can see that we have a perimeter of 10 inches in shape 1 and a perimeter of 14 inches in shape 2. And there you have it. Mystery solved. The answer is yes. You can have 2 different shapes that have the same area but different perimeters. Thank you so much for watching. Be sure and join me next time, and you guys have a great